Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will talk about timestamp based protocol. To achieve the serializability other than the locking protocol, we will know that how timestamp can be implemented to give us a protocol to ensure the serializability. Also, we will talk about the Thomas Wright rule that will be a modification to the timestamp based protocol. As per we know that we can provide and grant different type of locks to provide the serializability to ensure the conflict serializability of two relations or two transactions. Now, whenever we are talking about transactions, we must ensure that the transactions are atomic and durable in nature. When we are following the atomicity, then we must provide that all the statement of a transactions are performed together. That is the part of a serial schedule. A serial schedule can contain more than one transactions which complete their transactions or the statements together in a part of the schedule. That is, no two transactions are conflicting if they do not have a single data item access, each of this at least one write to them. Now to ensure this one, we have introduced a locking protocol. But the locking protocol itself has got some disadvantages which now introduced to another protocol. What we will discuss today is the timestamp protocol. Now the timestamp means for to data access on any item, what time it is taking by a transaction. That is, we were introducing as a timestamp of the transaction. Now the timestamp of the transactions is generally defined by the access time on a data item by that transaction, and it is defined as TS brackets the transaction name. So if we are specifying TS brackets TI, that means we are specifying the timestamp of transaction TI on a particular data item. Now if we specify like this, TSTI is less than TSTJ. That means there arrives in the schedule another transaction TJ which appears before and after this TSTI. That means TSTI has appeared first, that is why its timestamp is less than the timestamp of TJ. So it is the arrival time of one particular transaction. At the complete of one transaction, we can assure that the another transaction is starting. Now, if this one is defining, then we have two problems or two issues that are associated with this protocol. The first one is the timestamp or the system clock. The system clock value measures the timestamp of this transaction. That means when the system clock SI denotes that TI, that means we are saying that TI has entered on the system clock value SI. So now my SI equals to TSTI. That means the transaction TI has entered into the system. Next, into the logical counter. The logical counter stands for that after the TS has entered or the TI has entered the system, now we need a counter that for how much time the transaction is completing. Say for instance that it has started for SI, now for every seconds we are adding one logical counter to it. Now the logical counter will be incremented by +1 with every second the transaction is spending time on that statements. Now after that, on SI plus LC seconds, we know that that is a logical counter value of TI that will be entered for TJ. So now my SI plus LC will be equals to TSTJ. So these two values with the system clock and the logical counter, we can determine that at which time a transaction is entered and for how many time or how much time the transaction is spent on this statements on a schedule. Now, if we can follow this one that TSTI is less than TSTJ, then we are ensuring that there is one TI that appears on this TJ. That means TI belongs to a schedule S, which is a schedule schedule. Now we can say that TJ also belongs to S, which is a schedule schedule. So now TI and TJ both belongs to S, and both can have this ordering that TI appears first, then TJ appears in serial schedule S. So now we are producing a S schedule which defines Ti first, then all the transaction statements from the transaction Tj. So these following orders go for a timestamp based protocol. That means now we need to introduce two timestamps. One is read stamp, one other is write stamp. Now when we can introduce this read stamp or W stamp or the write stamp or this R stamp, then we are specifying that it is on a particular data item, not by a transaction. So the transaction timestamp is known as TSTI, whereas in a data access we need the W and R timestamp on this data item. So if we can suggest that W timestamp on Q, that means we are specifying it is the largest write timestamp that can access on this Q. So if there is a set of Ti to Tn, then we can say that W timestamp Q for each one is the largest, that means greater than all this Tj which belongs to write on Q. So now if there is a new write, then we will compare the value of that transaction's W timestamp Q with the previous W timestamp Q, and if it is the larger one, then we will make the new transactions write as my W timestamp Q. Now the read timestamp Q or this R timestamp Q suggest for if there is any transaction Ti to Tn that is greater than Tj for read Q. That means it is the largest timestamp for any transaction which is performing the read data access on data item Q. Now on this type also we are having that the read is new there, then we need to compare the new read timestamp with the previous R timestamp on Q. If it is a larger one, then we will assign this R timestamp Q as the new read Q. Otherwise we will prevail the previous one onto this R timestamp Q. Now that we know about TS, R timestamp and W timestamp, we can define our protocol, that is a timestamp based protocol, to achieve this serializability. Now the timestamp will have two issues with us. One is the read insertion, another is the write insertion. First we will talk about the read insertion. Suppose that the transaction Ti has issued and read on this data item Q. That means Ti has issued read on Q. Now if this read Q is validating on next two conditions, then we are saying that we are having valid or invalid read. Now if the transaction time that is less than the W timestamp Q, now that we know that W timestamp Q is holding the largest value for the write on data item Q, that means it is belonging to the transaction that has taken the largest time. Now my TSTI is less than this W timestamp Q, that means the transaction has happened over the time period and before this W timestamp Q. That means the transaction Ti needs to access a data item Q that has already been overwritten. So now Q is being overwritten. So my TSTI on read Q is rejected because we are achieving a value that has already overwritten. So we do not need to read such values because the write is being performed before the read is happening. So now my TSTI is rejected. And it is rolled back. Now what happens if it is greater than equals to W timestamp Q? Now we can say that my TSTI is greater than equals to W timestamp Q. That means my transaction has a larger value than the write on this data item Q. That means the transaction is now happening after the actual write on this data item Q. The largest write item means the last data item Q that has been written by a transaction, and my TI is happening after that transaction. So now TI can proceed this read because the writing has been done. Now it needs to be read by the transaction. So my TI is granted, and we need to set this R timestamp Q because the maximum of this TSTI and this R timestamp Q. So now my R timestamp Q goes for the max of R timestamp Q and read Q. So now we can say that the maximum of this R timestamp and read, which has the maximum or the larger value, we will set that value to our R timestamp Q. So this is for the read operation. Now what happens when TI issues a write operation? Now the value we are using is the first one, that is TSTI is less than R timestamp Q. So now we are having that my transaction which is for the write Q is happening after the R timestamp Q. That means it is writing a value that was already needed or previously needed, and it is assumed that the transaction would never produce this value. That means the read operation has already been performed, and now we are having this TSTI, that is the greater value on this R timestamp, that is happening after the read. That means we are writing a value that we will never use. So in this assumption, it just rejects this TSTI on the write Q and roll back the value. So now my Q is already written as the result. That is why we will reject the TI. Now, if this TSTI is less than the W timestamp Q, now we can say that the transaction which is issuing a write operation on data item Q is less than the W timestamp Q. That means the W timestamp Q means already the data item has been written, and now we are writing an overwritten data. That means we cannot perform that after the read operation has not been performed, and we are issuing another write operation on the data. Say suppose that an account that is being updated within subtraction of 50, now other than updation on the data by this another account which it is transferring the amount, it is again gaining and plus 50. So now it would result in the same, that is not desirable because that is a result that is not durable. So now if this happens that TSTI is less than W timestamp Q, so we will reject the transaction because Q is being overwritten. Now if it is not less than R timestamp Q, not less than W timestamp Q, then in other cases it can perform the write operation that already the read operation has been performed, or the write operation has been performed followed by a read operation. So now it can perform a proper write operation on a transaction TI. So now we can say that the write operation is granted, and we can set the W timestamp Q to the maximum of this write Q and W timestamp Q. So now this is my timestamp protocol. Now my timestamp protocol is saying that if there is an obsolete value or an overwritten value or the value that we'll never use, we are rejecting the read and write operation based on these conditions and rollbacking the transaction to the restart. That means the transaction need to restart as a fresh one with new conditions, so that this condition will never arise. Now let us take an example and define the protocol again. So my first transaction is reading two values and then displaying the summation of these values. And my second transaction is for transferring an amount 50 from the account B to account A. Now what we can see that this transaction T1 and T2. So now if we are assigning the system clock SI to these transactions before happening on T1 and T2. Now we can say that T1 and T2 has been performed with the system clock SI, and it will be assigned a timestamp TS to each of them. That means that T1 will appear first and T2 will appear next. Now if this transaction TS T1 is less than TS T2, then we can say that the transaction has been happened for this transaction and before it. Now the transaction T1 and T2 can be performed by following all the transaction on timestamp based protocol in a seamless way. Now what happens that sometimes we are producing a schedule that can be achieved by a two-phase locking protocol, not the timestamp based protocol, and also by the timestamp based protocol but not the locking protocol. Now this type of issues can be solved because the timestamp based protocol are producing a schedule which is free from the deadlock situation, because the transaction that will never wait for write or read queue if any of the condition is not matching, and it will roll back by the transaction. So there is no question of deadlock in this timestamp based protocol. Now let us define a schedule that we can achieve by this timestamp base but not the two-phase locking protocol. First we are issuing and read operation, that is B, on this T1. So now there is no transaction, so the read B can be done because there is no question of rejecting it. Note W timestamp on this B that has been performed. Now on transaction T2 we are performing this read B again. Now also the read is not less than equals to the W timestamp, so this one will be performed, and now we have this B updation with B minus 50. Now when we'll try to write this value, that is W timestamp of this B, now it will be assigned because it is greater than the R timestamp of B, and also it is greater than the W timestamp of B because there is no write operation that has been performed to B till now. So now we can say that we are performing this write B on T2. Now again come back to T1, we can perform this read operation on data item A. Now we can perform this read on data item A for transaction T2 also, because there is no transaction who is having the W timestamp queue that is less than the read queue or this TS T2. So it will be also performed by this T2. Now if we perform display A plus B, then we are having the previous value of A and the new value of B because the B has been updated by T2. So now if A contained 100 and B contained 300, so now 250 it becomes. Now we will have 350 in this result of this display. Now when we are performing the next one in this T2, see now my data item has read A only. So now we can generally write this A because this W timestamp on this A has not been there, and it is also greater than this R timestamp on A because it is reading a value that is being not used till now. So now we can write this value and then we can also display the value on T2 transaction. So now we can have an updated value on A, that means it will be updated with 150. So is this result we are having 400. So this is an intermediate result of 350 because the A's value has not been written till now, and now the written value of A and B both will come up with the result 400 in this way. So now we can see that the timestamp based protocol is producing a schedule S that is serial, and we are also ensuring the conflict serializability, because if there is some conflict operations on any data items, that is we can see that read B, write B, read A. So there is no data item that has been performed in two of the transactions consecutively with each of this write or at least one of them write operations. The next one is read and read, next one is display, and finally it is write. So there is no conflicting operation because the timestamp ordering protocol supports that no confliction will be there, because if it is the less than W timestamp Q on a data item, then we are prevailing that portion that we cannot have a write and after that on a read from different transactions, because it will not follow the timestamp based protocol. So now we can have an conflict serializable as well as deadlock free schedule for this timestamp based protocol. So now we can see that this S serial is serial, conflict serializable, and also it is free from any deadlock situation. Now we know that this much conditions or the provisions we are having from this timestamp based protocol, but it does not support the recoverability. That means the recoverability property is not attended by the timestamp based protocol. However, if we modify this protocol with some of this condition, we can ensure the recoverability too. Now, if we can produce the all write on this timestamp based protocol and the writes are being performed at the end of the transactions, that we can ensure the recoverability and also the cascadelessness. So now we can see that we are having all the transaction TSTI that is less than this W timestamp Q. That means all the writes are greater than the value of the transaction that will be performed at the end of the transaction. Now the next one is if we can provide by this transaction that all the uncommitted writes that we can roll back, then also we can ensure the recoverability. So now we are providing some kind of locking to this timestamp based protocol so that all the uncommitted value, and if it is not updated on a data item Q, then the TSTI will not be committed. So now in this way we can produce this recoverability and cascadelessness. But we can also produce this recoverability only if we are saying that we can restrict this transaction TI to have a timestamp TS, and also we can say that there will be no uncommitted writes before the transactions can be committed. So now we are specifying that there is no uncommitted write on the Z item Q before the TSTI can be committed. So it will be committed after all successful completion on the commitment of an write Q. So in this three-way we can say that we are having the recoverability option supported by this timestamp based protocol. Now we can see that some of these conditions are not prevailing an issue to produce a serial and conflict serializable production on these transactions. Now what happens? For that we will exemplify another one. Now if we have for a transaction T1 read queue, that is T2 on this write queue. So we can guarantee this write queue on a transaction T2 because we can say that TS-T1 is less than TS-T2, and also the TS-T2 on this write queue as having greater than at timestamp on Q. So now we can say that this write queue can be performed after this read queue because it is greater than the value of this read queue. If there is any transactions write queue that has been based on this T1. So now we are having TS-T1 that is greater than TS-T2, and also the write on Q is trying to write an obsolete value, or that the value Q is written on this transaction T2 which has not been read. So now we are rewriting an overwritten value. So this TS-T1 is less than the W timestamp of Q. So we just cannot allow this write queue to be happen because it will produce an undurable value for this queue. The first condition is the value is not being read by any of the transaction that has been written by this transaction T2. Now we are overwriting a value. So we can say that the R timestamp Q and the W timestamp Q both will be same for this case, which cannot happen by the protocol that we have defined for a timestamp based one. So now what we can do? We can produce a rollback on transaction T1 that was supposed to do by this protocol, but it is unnecessary because this read queue was already being reading and value that has been written by some transaction. So there is no possible way to doing that, and it is absolutely unnecessary for restarting the transaction from the beginning. So now what happens in some circumstances, it becomes necessary or to give permit to a write operation that has not been read by any of these transactions. So now this modification gives up the new rule, which is known as Thomas-Wright rule. So by the Thomas-Wright rule, we can eliminate this type of problem that we are writing a value on a transaction that has not been written or read by this any of the transaction which is involving the writes. So now we can define our Thomas-Wright rule as, so the Thomas-Wright rule goes for the timestamp based protocol with just one modification in the write rule. The read rule will be same like this timestamp based protocol. So the first one is that TSTI is less than this R timestamp Q. So that means that the value of Ti now being an obsolete value that was needed previously, but it is assumed that it will be never used in this future. So the Ti is rejected and roll back on this Ti. That is the R timestamp queue, not this W timestamp queue. So it was same like this timestamp based protocol. Now the second one is TSTI is less than W timestamp queue. Now what happens that Ti wants to write in value that has been already written by another transaction, and now the value is not read by another transaction. So what we are doing, other than rejecting the Ti and having this rollback, we are only ignoring the write operation. That means the next write queue we are ignoring and will continue with the transaction by the following statements. So now my Ti is not rejected but ignore on this write queue. And now we can follow the previous transactions. And the third one is any other cases where this TSTI is greater than W timestamp Q and also greater than R timestamp Q, then we can produce the Ti is granted on this write queue. And the W timestamp Q will be based on this maximum of W timestamp Q and this write queue on the timestamp based protocol, but here we are modifying as the W timestamp Q will be the write queue value because we are having a write operation that has not preceding any read or write operation. So my W timestamp Q will be assigned with this new write queue. So this is the modification based on this Thomas Wright rule. Now we can say that we can produce a schedule that is not needed by this rollback on the transaction T1 that has been performing a write operation after the write operation on transaction T2. Now we can say that it can produce a serial schedule that is not conflict serializable. So it is possible for us to generate a serial schedule that is not conflict serializable, which is introducing another one, that is view serializability. Now we can say that the Thomas Wright rule can generate the protocols or a schedule that cannot be generated by any other protocols, because the two-phase logging protocol and also the primary timestamp based protocol are producing a conflict serializable but not allowing to ignore an obsolete write operation or ignoring or deleting the write operations that can be write and overwritten value. So that is all for the timestamp based protocol. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.